Okay, let's quickly review the electrophysiology of the heart. And the first thing that we're going to talk about are the types of cardiac cells. So there are two kinds of cardiac cells. There is pacemaker cells, and then there are the muscle cells or myocytes. And there are four characteristics of cardiac cells, and they are automaticity, excitability, conductivity, and contractility. Contractility, sorry. Okay, with respect to the characteristics, automaticity is the ability of the pacemaker cells to generate their own electrical impulse in other words, to depolarize on their own. Excitability refers to the cell's ability to respond to an electrical impulse. Conductivity is related to the cell's ability to conduct an electrical stimulus onward, so help propagating it onward. And then contractility has to do with the cell's ability to shorten or to actually contract, which is why it's characteristic of the myocyte. So in terms of automaticity, pacemaker cells have that characteristic. In terms of excitability, both pacemaker cells and myocytes have that capability. In terms of conductivity, both pacemaker and cardiac myocytes have that ability. And in terms of contractility, cardiac myocytes have the ability to shorten and contract. Okay, well, let's look at depolarization. Oh my goodness, my marker's not working. Depolarization. Okay, and basically, we'll let this be the cell, and there's the extracellular space and the intracellular space. Okay, outside the cell and inside the cell. And when we talk about depolarization, we talk about ions. And there are the major ions that they discuss in the chapter, and there are more, but the major ions they discuss in the chapter are potassium, and I'm going to put it inside, and sodium, and I'm going to put it outside. And then another key player also is calcium. Now, ions in solution have a charge. So that's important to remember, because every potassium ion has a plus charge and every sodium has a plus charge, and calcium actually has 2 plus charges, if you remember some chemistry. But ions are not neutral, they do have a charge. And if you can recall, in terms of polarity, like charges repel and then opposite charges attract each other. Okay. The resting state of the cell is polarized. And so they have much more sodiums on the outside than they do on the inside. And that's the resting state of the cell, if I drew a couple in there. And there are more potassiums on the inside of the cell than there would be outside of the cell. Okay? But overall, there's much more positive charge on the outside of the cell and less positive charge on the inside of the cell. So the textbook talks about being positive on the outside and negative on the inside. And yes, there's more calcium also on the outside of a cell, cardiac cell, than there would be inside of the cell. Almost none, and actually stored in sarcoplasmic reticulum, but we don't have to get too fussed about that. All right, so the ability of ions to move across the cell is dependent on the characteristic of this cell membrane and also the charge. So there are a couple of different ways that ions can pass through, and they are going to want to move. So the want of ions to move is going to depend on two things. One is the concentration gradient. So if you can imagine, if I just opened the door here, with there being so many sodium ions on the outside and none on the inside, sodium's going to want to go from an area of high concentration to low. So we go from high to low here. So they'd want to come in just by the concentration gradient. The other concept that you need to know is that there's also an electrical gradient. And that means that like charges, so like want to repel, and opposites attract. Okay, so again, because there's so many here and they're all positive, and it's mostly positive here and a little less positive inside, the electrical gradient would also push sodiums inside. Okay, so there's a concentration gradient that moves ions, or that promotes the movement of ions, and there's also an electrical gradient. I'm just going to move the ions for a second. Okay. The resting state of a cell we call polarized. That is, our cells continually work to maintain more positive charge and less positive charge, or if you want to think of it as negative inside. So a stimulus comes along, and sometimes they're a little bit, the membranes are selective, but they're a little bit leaky. And so, you can get a potassium kind of leaking out just by kind of diffusion, and if the membrane is permeable to it. So simple diffusion can happen across the cell membrane. But we also have other things called channels. And sometimes those channels, again, are just doorways that can be opened or that remain open. And sometimes they are doorways that, once this polarized state across the cell membrane changes a little bit, so this becomes a slightly less positive, or this becomes slightly less negative because a few potassiums has leaked, then the difference across the cell membrane changes. When that change happens, what we call voltage-gated channels open, and they become open doorways. So there are some that are already open. There are some that are, there are channels that are, so the cell membrane can be open. I'm going to leave that open like that. And there's some that have a lid that will open up if the membrane potential changes, and they call them voltage gated. And then the other concept that they have inside of the textbook is they talk about the sodium-potassium pump. Okay, so all of these concepts work to depolarize the cell. So a stimulus comes along, and the membrane potential changes. Some of these potassiums start to leak in, some of these sodiums come flushing in, and depolarization happens. So where resting state is polarized, when the membrane potential changes, or the charge across the membrane changes, and ions are influx or efflux out, in and out of the cell membrane, then we call this depolarized. And then once we've depolarized, the cell membrane has depolarized, it triggers whatever this cell was designed to do, in this case, a cardiac cell, and if you're thinking about a myocyte, it was evolved and designed to contract. So once depolarization of any cell in our body happens, whatever that cell's work, specific task, whether you're a neuron, so that's to propagate an impulse or a messaging, or release a neurotransmitter, or in the case of a cardiac myocyte, that is to shorten and actually facilitate the pumping of the heart or contraction, the work happens. Then the cell goes to homeostasis, we rely on. The cell goes to repolarize. Okay? And that's when we use energy. The cell actually uses energy to restore the original polarized state. And so in this case, it's going to pump sodium out and pump potassium in. Actually at a 2-to-1 ratio, but that's kind of irrelevant. But basically the concept is with the pump, it's expending energy to restore this polarized state across the cell membrane.